Everything you know about your appearance is an accident. Why do you have skin and not a shell? Because Earth's atmosphere is gentle, not burning. Then you might ask me, if Earth is so gentle, why does a turtle need a shell? And you'd be right. But the truth is, the turtle's story required armor. We stand on 2 feet because gravity holds us just right, not crushing us, not letting us float away. Our eyes aren't the pinnacle of evolution. They're just tools fine-tuned for sunlight. Change the world, and everything we call normal becomes obsolete. So what if we move to other planets? Not over-zoom, I mean fully, body and soul. You wake up on Jupiter, or Venus, or on some frozen moon of Neptune. What would you look like? Would you still be human, or would you become something new? Take a seat. I'm about to take you on a journey through the universe, but not dry and dull, like that physics teacher on Monday morning who mixes up planets with pastries. No, this will be vivid, fact-filled, and full of revelations that'll make your inner universe whisper, "Whoa." And believe me, after this tour, you won't want to meet the version of yourself from Venus. This is Mars. It's believed that this is how it looked several billion years ago. A dense atmosphere of carbon dioxide enveloped the planet, retaining heat and moisture. Numerous rivers flowed across its surface, and much of the northern hemisphere was filled with water. However, all of this was destined to disappear, leaving only traces on the rocks. It's assumed that Mars's weak and unstable magnetic field couldn't protect it from the solar wind. Over hundreds of millions of years, the atmosphere gradually thinned, and water vapor broke down into hydrogen and oxygen. The lighter gas rose to the upper layers of the atmosphere and escaped into space. Oxygen reacted with the rocks, slowly covering the planet with a coating of rust and sand. A thin layer of orange dust and permafrost. That's all that's left of the red planet's watery abundance. Now, you're on Mars. The first thing you notice, the sky isn't blue. It's reddish. You look out the porthole and think, is this Texas on a bad day? But no. You're on a planet where gravity is 2.6 times weaker than Earth's. So the first change, your legs. They'd likely become longer. A pleasant thought, especially if you've always dreamed of a model-like appearance. And your rib cage, larger. To inhale more oxygen, since there's essentially no atmosphere. You can't breathe there, unless you're a mutant, of course. Moreover, due to constant dust storms, your eyelids would be covered with a membrane, like in lizards. It doesn't rain on Mars. The planet's weather is such that it's either extremely hot or extremely cold. As a result, water instantly turns into vapor or ice. But there is snow, composed, however, of carbon dioxide, so we definitely don't recommend eating it. The snowflakes are so tiny that, seen up close, we'd mistake them for snow fog. But here's the thing. If you were born on Mars, your skeleton would be different. Lighter, yet expanded in the upper part. And you'd look like an Earth marathon runner if they were stuck on an oxygen cocktail diet. Lucifer, Phosphorus, Ishtar, Morning Star, Earth's twin. All these resonant names belong to the same celestial body, Venus. Being the third brightest object in Earth's sky, this planet has always attracted the attention of researchers. Dense, opaque clouds hiding its surface have for years stirred observers' imaginations, making them envision endless oceans or dense jungles inhabited by monsters. Venus is the second planet in our system in distance from the center. It's located 0.72 astronomical units from the Sun, and its orbital cycle is about 225 Earth days. Every 584 days, the distance between Venus and our planet shrinks to a minimum, approximately 0.25 astronomical units. In its physical characteristics, Venus is in many ways similar to Earth. Its average radius is 6,052 kilometers, or 95% of Earth's, and its mass is 4.87 times 10 to the 24th kilograms, which corresponds to 0.82 of our planet's mass. Venus completes a full rotation around its axis in about 243 days, and the planet's axis is tilted at an angle of 3.4 degrees to the plane of the ecliptic. The temperature is almost 500 degrees Celsius. The atmospheric pressure on Venus's surface is 92 times greater than on Earth. In other words, the pressure is such that you'd be crushed like a tin can under a press. But let's imagine you've evolved. What kind of skin do you have? You wouldn't have ordinary skin. You'd have a thermal shell, like a super-protected satellite, only alive. Armor, dark, like charred titanium, covered with layers of silicon and sulfur compounds to reflect the furious heat and acids of the atmosphere. You wouldn't tan. You'd reflect death. Eyes, narrow, multi-layered, with protective filters, built-in thermal adaptation, and possibly a third eyelid, like in reptiles, something between a welder and a future lizard. They wouldn't look, they'd scan. You move slowly, not because you're lazy, but because every step is like marching through a sauna, where the temperature is over 450 degrees Celsius, and instead of steam, sulfuric acid. Gravity is almost Earth-like, but every movement feels like it's mixed in hot jelly. A Venusian is a grounded Terminator. He doesn't melt. Everything around him does. Beautiful? Perhaps. If you're thrilled by nuclear disasters and post-apocalyptic movies. He doesn't smile, because the smile would be the first to melt. Welcome to Titan, the largest moon of Saturn and the second largest moon in the solar system. It's not just a lump of ice and gas. It's the only body besides Earth where liquid stably exists on the surface. But there's no water here. Here, it rains methane. Rivers flow with ethane, and entire seas, like Kraken Mare, stir in the dense atmosphere under the pale light of Saturn. The surface temperature is minus 179 to 180 degrees Celsius. It's so cold that oxygen becomes a solid, carbon dioxide crystallizes, and gasoline and motor oil turn into frozen blocks. Titan's atmosphere is denser than Earth's, about 1.5 times. You could walk without a spacesuit if you had a mask and thermal insulation. Life could exist on Titan that doesn't resemble Earth's. Instead of water, such beings might use liquid methane. Scientists from NASA and the European Space Agency are already conducting experiments in special freezers to see what such life might look like. If it existed, it would breathe not oxygen, like us, but other substances, like peroxide or nitrogen. These substances could slowly initiate chemical reactions, even in such extreme cold. Now, imagine you were born here. You're a local. Naturally, you wouldn't be human. You'd be the product of a long, frighteningly logical adaptation. Height, about 2.5 to 3 meters. On Titan, gravity is weak, about 1/7 of Earth's, so your height could be greater, and your body more massive without the risk of collapsing under its own weight. Mass, high body density, a large amount of fat and protective layers, but weight, small due to gravity. On Titan, you'd weigh only 12 to 20 kilograms with a mass of 100 to 120 kilograms. Skin, not just rubbery. It's made of a multi-component biomaterial, micropores covered with fat-like resin that don't let liquid methane through. It's a living sealant, a biosuit that regenerates micro-damages and can change permeability depending on conditions. Subcutaneous layer, like in Arctic animals, but improved. Fat with nanostructure retains heat and distributes pressure. You're a walking thermos. Eyes, wide, yellowish golden, with built-in filters for perception in the orange and infrared range. This is necessary since the sun here is 100 times dimmer than on Earth. Lungs. They're not for oxygen. They're reactors processing methane vapors, extracting energy through exotic biochemical cycles. Perhaps you can even break down nitrogen, which makes up 98% of Titan's atmosphere. And here you are, swimming in Kraken Mare, a dark, viscous, and hostile lake. It's larger than the Caspian Sea. On the surface, waves of ethane, deeper, layers of liquid methane. The water temperature is nearly minus 180 degrees Celsius, but your body glides through it effortlessly, like it's your native environment. Methane seeps into your pores, triggering a biochemical cycle, almost like photosynthesis, only cold. You don't eat, you synthesize. You know what's the most fascinating part? In trying to imagine what we'd look like on other planets, we forget one important thing. We've already adapted to thousands of environments here on Earth. Some of us were born in the Sahara, some in the Arctic, some underwater. Well, almost. Our bodies are masterpieces of adaptation. We are aliens, just from the perspective of other worlds. Earth is our cosmos. We just don't see it that way. And what if someone's already watching us, wondering, I wonder what we'd look like on Earth? We dream of other worlds. And that's a good thing, because when we imagine who we could become, we better understand who we are. And maybe one day, on a distant planet, someone will say, they looked strange, but damn it, they were beautiful. If you found this video interesting, leave a like and share it with your friends. Every bit of your support helps us grow and create more like this. Subscribe. This is only the beginning.